So the topic that I would be presenting today is about using GitHub as an autonomous and self-sustaining product in a large organization such as ours. I will start with a bit of an intro about myself. I'm currently working as an engineering manager for the delivery engineering team in Scout24. The team is responsible essentially for everything source control, so essentially building, developing, testing, CI/CD, and release engineering. So that's what the team is responsible for. I'm also leading a team currently which is responsible in the company to move everything from the data centers to the cloud. And we have an aggressive timeline ahead of us, so we are planning to shut down our data centers by August. I'm originally from Pakistan. I moved to Germany 1.5 years ago. I still consider myself a bit new because I still haven't learned German yet, but I have plans to. Before joining Scout, I was actually working for a Silicon Valley-based startup, so I'm also a big fan of the California weather. Little bit into the agenda. So we will go over intro into Scout24 quickly and the platform engineering teams, and that what have we been striving for when it comes to the source control tools, and how did migration look like to the GitHub Enterprise Cloud, how we actually managed to automate a lot of things around GitHub, and did we manage to actually reach our goal that we set for ourselves in the beginning. So about Scout24. It's mainly composed of two main businesses, Immobilien Scout and Auto Scout. Immobilien, they're online digital marketplaces for real estate and cars. They're actually present in 18 European countries right now, and we also have roughly 500 to 600 engineers. We have offices in Munich, Berlin, Barcelona mainly, but also we are present in Vienna and Hamburg. So yeah, it's a medium-sized company in terms of the size, and the department that I'm working in is platform engineering. So in the tech department in Scout24, we actually categorize into product teams and platform teams. Platform teams, the whole purpose is to enable the product team so they can focus on providing value to the end users and customers, and we take away the complexity of the infrastructure layer or platform layer from them. So just to give you some more context on that, where we essentially started off from in Scout24, it was made of really independent teams. So within our different verticals, which are Immobilien Scout and Auto Scout, the teams were actually responsible for the end-to-end tech stack. So they were responsible for the lower platform infrastructure layer, and they were also responsible for all the things happening at the application layer. So they had to actually learn all the tools at all levels and also build up their own tools, and they were also responsible for making the choices of which tools should they actually use at the end-to-end level. What we have brought in with the platform model or the platform engineering is essentially we want to abstract away the platform or infrastructure layer from these product teams. So we take away all that abstraction so that they can move up the stack and only focus on building stuff at the application layer. So they don't have to worry about the underlying platform at all. This also helps us, like if we have to move engineers between the teams a lot, they don't have to learn platform tools every time they're moving between teams, and they also don't have to spend a lot of time and effort into learning that area. Also, in the past, for the teams, they had to have a lot of software engineering knowledge and segment domain knowledge, but on top of that, they had to also learn about all the infrastructure stuff. So with this, they can actually save some extra time, and they can spend their time on self-development and other core innovation projects. So that's also something that we are trying to work on. This is, of course, not easy. We have a lot of challenges moving the organization to this platform model. So if you're also interested to talk more about this, how are we doing it in the company, and what are the challenges we are facing, I'll be happy to talk about it afterwards. So talking about that, where did we start on actually on the source code management or source control landscape in our company? So when I joined Scout in the beginning of last year, this is how it looked like. As in many companies, we had GitLab on-premises, we had GitHub Enterprise on-prem, we had Subversion running in the company, and we also had GitHub.com, which very few teams were using. So this is how we initially started off in the company with a lot of different tooling on source control. It was, of course, a lot of effort. So we had code repositories, which was also scattered across different tooling. So we had, as you can see here, repositories in each of these source control tools. The users were also split and scattered. And we had a lot of support requests coming because of we had so many different tools to manage, and it was really hard to maintain it all at the same time. So one thing very fast became apparent to us that we need to converge to one tool that we can provide to the whole company so that developers don't have to learn 4 different tools for source control if they're, for instance, moving between teams or working on various kind of projects. So we set essentially 2 goals for ourselves. The first one, to converge to one source code tool in the company so that we have only one that we are using across whole of Scout. And the other one was a rather aggressive one, that we wanted to have less than 1 support requests per day for source code management topics. So as admins or as owners of these topics, we wanted to build an autonomous system where we are not spending a lot of time and energy just looking into the topics around these areas. So we wanted to build sort of an autonomous, self-sustaining system where we have to spend the least amount of effort. So how did we decide for one tool initially? So there were certain metrics or areas that we considered. The first one was, of course, we were looking for a tool that is sort of an industry standard, so that has a good reputation in the industry and is also like integrates well with different kind of CI/CD tools. We have managed Jenkins solution in the company, and we are using Artifactory for our artifact management, and we have also other tools, Jira and others, which we had to integrate with. Also, it had to like follow the best practices that are set by the industry. The other thing that I also already mentioned is like it had to be as autonomous as possible. So minimum maintenance is required to run it in the company, and we don't have to spend a lot of time and effort there. So essentially, it provides automated user provisioning, deprovisioning, these kind of things. And of course, we did not want to compromise on the security side of things. So it had to be secure and reliable, so we are not running into a lot of issues around this area as well. And we also wanted to pick something which has a strong community around it, so which has a lot of people behind it, which is actively being worked on, and it's something that we can strongly rely on and is growing every day. Because what we also really believe in is we are collaborating a lot for open source and inner source projects. So, and last but not the least, the one thing that we were also considering was, as I mentioned in the beginning, we are migrating to the cloud completely. So we wanted to opt for a solution which is not self-hosted. So we wanted to go for a solution that is provided as a service and is available in the cloud and is hosted for us. So we have to spend less time and effort to also maintain it. And yes, it had to be financially viable as well. So it's something that falls into our budget. So what was the lucky winner? It was, it has changed names a few times. It used to be called GitHub.com and then GitHub Business Cloud, and now it's called GitHub Enterprise Cloud. So that's the offering we went for. And it actually comes with the, some of the features already that I mentioned. So it is, you can choose between self-hosted or cloud-hosted. We went for the cloud-hosted solution, as I mentioned. It also comes with the SAML single sign-on, so it's really secure in that sense. The access provisioning is built in. But I think one thing that was also really a big plus point for us is the simplified account administration, which is what I also mentioned before. So I'm not going to go into the detail of how we did the actual migration from different tools to GitHub Cloud, but I will just share some common tips or things that work for us. So one thing is, of course, very important. So we had to communicate a lot. So we had to, it's also like a cultural change, this whole platform model that I was talking about, that what is the need behind moving to one common tool? Why are we choosing this over the other options that we have in the market? So we had to like communicate a lot with the teams. We published a lot of FAQs that we distributed across the organization to explain to the different teams that why are we making this decision. We automated the tooling or the whole workflow for migration, so it was sort of least disruption for the teams, and we had it we were not conducting it in a manual way. Also, what worked for us was to minimize disruptions for the teams. So we had like particular days, or in this case, we had like a migration week where we said that this is where it will happen. And within that week, we had like individual slots for each team. So there's minimum downtime when we are performing the migration. So it's not like for 1 week, everything is down and you cannot access the code base anymore, but rather it's split in a per team basis. And lastly, of course, dry runs are important. So we did dry runs to make sure that everything is working fine before we actually performed the migration. So what is the status quo right now? We have right now 3,300 plus repositories running in the organization. We have roughly 540 users that are in the Scout24 GitHub org. And you can see we have also roughly 300 public repositories that are on the organization. So we have right now migrated from all the other tools, but there are still some legacy subversion running in the data center, which we are planning to migrate in the next couple of weeks. But everything else now is gone from the organization. So on the goal check, at this point in time, we had migrated mostly to one tool across the company other than SVN that I mentioned. But what about the support requests? Did GitHub Enterprise Cloud solve it for us right away? Not so much. So we had to build some things on top. And that's what I will actually be covering now. So that's the part where we had to actually put the automation on top to actually make it an autonomous tool that we can use in the company. So here comes the post-migration challenges, which is essentially lambda everything. So I want to start this with explaining like how is the general developer lifecycle look like in an organization. So when you have a developer who joins the organization, the first step is that they have to join your GitHub org, for instance. The second one is as soon as they're in the org, they have to get access to teams and repositories. So they have to join a GitHub team, and then they have to get access to all the repositories. They have to create their own new repositories, and then they have to start collaborating with other users in the organization. And the last step is when they're leaving the organization. So this is how a normal developer lifecycle look like. What I will do now is go through each one of these individual stages and then see how is it working for us right now and what automation did we have to build on top. And also, I will try to explain that by presenting to you different developer personas that are usually there in the company. So for the first step, when a developer joins the GitHub organization, we'll take example of this developer who's called Efficient Ed, who just joined the organization and is really excited to start working and coding right away on his first day at work. How it used to be in our company before was that somebody would join the organization and then they would start looking for help on how can they actually join the GitHub organization. So they would browse through the Slack channels, find out there's this GitHub community channel. They would ask there, hey, is there someone out there who can add me to the GitHub org? And then they would be presented with a long checklist saying, please provide this and this and this, and then somebody would manually add you to the organization later. So it was a really long and tedious workflow that people had to follow just to get added to the GitHub organization. How does it look like right now? So they have to go to this Scout24 link, so they have to log into it. They're asked to enter their Scout24 credentials. They have to authenticate using Auth0 and Duo. The video is stuck. But that's it. That's where they're in the organization. So I think the video is having some problem. But what is happening essentially in the backend? What's happening is when there's a user who's trying to log in to GitHub, they're asked to log in through their Scout24 account. And once that's done, they're asked to authenticate through Auth0, and we have two-factor authentication enabled, so they have to authenticate through Duo, and then they're connected to our Azure Active Directory. And once they're logged in, they also get access automatically to GitHub. So there's no manual steps needed now to add people to the organization. The user provisioning is now completely automated through this process. So this is also something that comes in with the Enterprise Cloud. So once they have access to the organization, the next step is then to get access to the teams in GitHub or get access to the repositories. So as soon as you get access to the repository, the first challenge that comes with it, and also this is, I think, a problem that people are more concerned about when they're picking up enterprise cloud is the code access and security topics. So the persona that comes to mind immediately is a developer who doesn't care about security and who is coming into work and looking at all the ways on how not to leak their secrets into the code base, and what are the best ways to actually store the API keys. So there's tons of literature and help material available out there, FAQs and stuff, but when they actually commit the code base, it sometimes looks like this. So there's still a possibility of leaking secrets or API keys into the code base. And what do we do in that scenario? So one solution is that we completely lock it down. So we lock down the access to all the repositories, and they're not able to work anymore. But there's also all these other solutions that are now available, like the token scanning solution that is provided now by GitHub. There's like Git secret tools and a few other tools, but most of these are pre-hook, pre-commit hooks, which you have to run on your code base before you are actually committing to GitHub. But what do you actually have to do when, for instance, in our case, we were migrating 800 to 1,000 repositories in a go, and we were moving them over to GitHub. So what do you do in those kind of scenarios when there is already a risk of some secrets that might be leaked in the code base? What should you do in that scenario? The option is to actually reduce the blast radius. So one option could be that you let it affect the whole organization, or you can actually reduce the blast radius and localize it only to the team who owns the repository and not have it affect the whole organization. How are we actually implementing that at Scout? So what we have right now is you have the option in GitHub to set the base permissions on org level. So you can set it to one of the possible options that are listed over here. What we have done right now is that by default, the permissions on the org are set to none. So users don't have permissions to clone and pull code base and make changes to it. So that's how it is set by default. And as a workaround, what we have done now is have this read-only team in GitHub that everybody is added to by default as soon as they enter the organization. So they're made part of this read-only. And it's up to the repository maintainers or admins that they can add this read-only team to their repository. So if, as a repo admin, if I have this team added to my repository, the whole organization can have access to it. There was also an announcement right now at the keynote with these internal repositories that will now be launched, which essentially I think would also solve this problem so that you don't have to put the workaround, but you can also make it either visible only to your team or to the whole organization, or make it public. So now there are 3 levels available. So that could also be a good solution to this, I guess. One other thing is, of course, the dependency updates. So if you have a code base in your repositories where there are dependencies that need to be updated regularly, how do you actually go ahead and update them and work on that? So the process we had also initially was really manual and tedious, and also it was really unreliable because we would manually go in and create pull requests for the dependency updates, and then people would or would not merge them into their repositories, which was not reliable at all. There was also an announcement at the keynote today, but we had done it also before. So we were using Dependabot, which is essentially this dependency management tool where they go scan your repositories for any new dependencies that are out of date, and they pull them in and then create automated pull requests for your repositories. So you can have the dependencies updated. One thing we are a bit ahead is that we merged Dependabot with the ProBot auto merge. So it's not that only automated pull requests are created, but if the requirements are met, they're also automatically merged into the repositories. Because a big risk that comes with this is that you can create automated pull requests, but people still can forget to merge them in, and then those pull requests can be open for months at large. So with the auto merge consolidation with this, we also make sure that the dependencies are merged into the repositories. There's a requirements file and configuration file where you can actually define the conditions, after which it will be merged, so it's not unsafe. You can say that we need a minimum approvals of, like, I don't know, 2 people before it can be merged. So in that sense, it's really safe before it's merged into your repository automatically. This is something that's really working well for us, and we get a lot of good feedback from the teams all around. All right. So then the next step is usually creating new repositories of your own as a developer. And I think a big risk that people associate with this is public repositories. So as soon as we hear about enterprise cloud, the biggest risk is that repositories can go public anytime, or you can create public repositories, and it's really insecure in that sense. And we think of a lot of incidents that people can cause when this is happening. So usually the concerns that people have is that repositories can be created accidentally in a public mode, or you can convert private repositories into public accidentally rather easily, because it's a click of a button and it's really easy to happen. Or you can actually import an existing project into GitHub, and then you can import it into public mode rather than private. And then everybody can have access to it. So these are the usual concerns that go around public repositories when it comes to enterprise cloud. So how have we solved it in Scout? So we have a thing called public repository killer. So it's not as ruthless as it sounds, because when we were discussing this, we did not actually want to fully block the creation of public repositories, but what we wanted to do was put an extra layer on top, so people are not making repositories public accidentally, but they're actually making the conscious decision when they're going ahead and making those repositories public. So how is this implemented really? What we have right now in the organization is a list of all the public repositories that are in Scout 24 right now, so it's essentially a whitelist. Whenever you have to create a new public repository, you have to add the name of your repository in this whitelist, and you're presented with a pull request checklist. So it asks you, are you sure you want to do this? Are you sure it's secure? Did you check with the legal requirements? All those things. And you have to check them on your own, and then you can make that pull request. How do we make sure that repositories are not going public without this? So we have these Lambda, which is essentially what I was referring to as the public repo killer, which is notified whenever there is a create event. So whenever there is a new repository created in the organization, or a private repository is made public, this Lambda is triggered. And it goes against and checks in the whitelist, and it sees if the repository name is already in the list. If it's there, then it goes ahead and does nothing. And if it's not there, then it immediately reverts this repository to private. So with this workflow in place, we have the surety that we won't have repositories going public which are not intentional. So we can completely avoid the incidents or accidents in the organization. If you want to be more strict around this, there are also some features that GitHub launched in the last few months where you can completely restrict repository creation by the members at a public level. You can also restrict the repository creation by members at all. So they're not able to create repositories on their own, and only the admins can do it. There's also another option in GitHub by default where you can restrict the members of the organization to convert the private repositories into public. So these are now available in Enterprise Cloud as well. So if you also want to use them, you can go ahead and do that. But for us, as I said, we did not want to restrict it completely, but we rather wanted to avoid the incidents that happened in the org. Cool. So after the repository creation, the next thing is then collaborating with other users in the org. And with the collaboration, the first thing that comes to mind is the outside collaborators thing in GitHub. So I think there are different definitions around what outside collaborators can be. Some people think of them as the non-members, who are people who are not members of your current organization, or they could also be individuals outside of your team who can collaborate to your repository. The problem right now with outside collaborators is before that, of course, we can think of a developer who, because they're really a common use case to add outside collaborators to your repositories. The problem right now is that for an organization which has SAML enabled at the org level, this restriction is not applied right now to the outside collaborators. So if you go ahead right now and add the outside collaborators to your org, they don't have to go through the SAML-based single sign-on workflow. They can still be added to the org without that, which is really insecure for the organization that has this implemented overall. So but this, unfortunately, right now is only applicable to your members only, the members of the org, but not to the outside collaborators. So the solution we have right now is another Lambda. It is triggered every time when you add an outside collaborator. And what it does in our org is that this Lambda checks this collaborator that was added against the list of members in the organization. So it sees if the person who was added as the outside collaborator is part of the org or not. And if it's not, they're removed automatically. So we, in our organization right now, do not allow outside collaborators which are not already members of the org. So that's how we circumvented the solution, problem. There's also, again, another solution now available by GitHub, where you can completely restrict members of the org to add outside collaborators. But the problem with this is that the owners or admins of the org can still go ahead and do that. So the owners can still make the mistake that they can add an outside collaborator who is not a member and who is not coming through the SAML-based single sign-on workflow. So that's the catch with this solution. Cool. So then the last part is leaving the organization. When a developer goes ahead and leaves the organization, and the biggest concern that comes with it is security risks. So if an employee is leaving who's not really happy when they're leaving or they've been let go, there are always risks associated to this, that they have access to the whole code base. And this was also the case with us in our org. So how it used to be was that people would leave the organization, and then people would come to us and ask manually on, can you please remove this person from the GitHub org as well? And it was really a manual process of removing people. How it is looking right now is another Lambda. So we have a user management Lambda, which essentially what it does is on a regular basis, it fetches all the GitHub organization users. So it has that list. It matches that user list with our active users in the Active Directory. So it compares both. And then it sees if there are any users that are not there on the Active Directory side, it removes them from GitHub as well. So this is completely automated, so we don't have to worry about removing people from the organization anymore manually. And it happens on its own. So this is also something that has come in really handy for us and saved us a lot of work. So back to the golden question, the only German phrase that I managed to learn in my time here. Are we there yet? Are we there yet? Are we there yet on the goal that we set for ourselves? Did we manage to actually put down the support request to less than one request a day? I would say yes, 90 to 95%. There are a couple of things that we still have open, because of which we still have to support users from time to time. But for everything else, we managed to do that. So what are the two things? So the first thing is, the one thing that is also still manual in our organization is how GitHub teams are created and how people are assigned to those teams. So that's something where people have to manually go create teams and then assign people to them. So what we are looking for right now is an automated kind of synchronization or alignment with our Active Directory. So whatever teams are there in the Active Directory are synchronized with what is there in GitHub Teams. So we don't have to also manage that manually. The good news is that there was something announced by GitHub a few days ago, where there is now on Enterprise Cloud also a team synchronization available. But this is something that we now will have to explore and see how that works for us and then automate that as well. The second thing is what I call as repository catalog. What essentially I'm talking about is, if you remember, we talked in one of the previous slides about we have the base permissions set to none right now. What this means is, in our organization, if you want to collaborate across different teams, there's a big number of users who don't have access to a lot of repositories. So they cannot even see what repositories are there in the organization right now, because it completely restricts all sorts of permissions. So it saves us from the security problems, but they're not even able to browse through the repository list and see what do we have. And this has an additional problem that people might be building things twice when there is something that already exists on in the organization. So essentially what we are looking for is a view-only mode, where people can browse through the repositories in the organization and see what is there. And they can also, and this should be without access to the code base, but just looking at what is the repository, what does it do, and who are the owners, just with the basic permissions. So what essentially we are asking for is more granular permissions from the GitHub side. So that's also what we are discussing with GitHub, if we can get that, or we can also work around that on our own somehow. Right, so in order to summarize what I just said, yes, it is possible. The good news is that it is possible to run GitHub in your organization as an autonomous, self-sustaining running system by putting in some tweaks and automation on top. I also got some, when we were discussing about it yesterday, some questions around the automation that we have built. Are we planning to make it open source so other people can also use it? Yes, we have started to think about it. And if you're also interested and you think it would be a good idea, please also reach out to me after the talk and we can talk about it. That's all.